Today we're going to talk about derived units. And so let's start with what is a derived unit. It's a combination of SI base units. They're produced by multiplying or dividing these units. And so let's just think about maybe a derived unit, not necessarily the units you would use, but if you're driving and you wanted a derived unit to express speed. Anybody have an idea what that would be? Just think about that for a minute. So speed is a derived unit because it's some distance per unit time. So if you're going to express this as an SI unit, it would be kilometers per hour. And so let's look at a table from our book. Oh, it should be down here. Where did it go? Oh, sorry, next page. We'll look at some derived units that are on in your book on page 40, figure 2.4. This table gives us the quantity, it gives us the symbol, the unit, and the abbreviation, and how it's derived, how it's multiplied or divided to get that unit. The ones that we will use in class, I'll highlight, so we'll use volume. Now this one goes over cubic meters, and the example I'm going to do today is going to be cubic centimeters, because centimeters are a smaller unit that we usually use in chemistry. We're also going to talk about density today. This gives it in kilograms per meters cubed. We use grams per milliliter or grams per centimeter cubed. We'll also in this year use molar mass. Here it gives you kilograms per mole, but we will use grams per mole in class. So let's just talk a little bit about volume and density for just a second. And I want to add, this is going to be volume and density that we talk about here. And so volume is the amount of space occupied by an object. And so the derived SI unit is cubic meters. Now this is a very large measurement, and so we will not use cubic meters for our calculations. A smaller unit is cubic centimeters. So geologists would probably use a cubic meter or even larger, but in chemistry we're dealing with smaller amounts, so we'll use the cubic centimeter. And then a non-SI unit, SIU unit to use to measure the volume of a liquid is, or non-derived unit is a liter. That's a non-derived, it's not a derived unit is the liter. or milliliter. Trying to add a little space to my paper here. So a non-derived measurement is a liter. Or milliliter. So liter is an L, milliliters ml. 1,000 centimeters cubed equals 1 liter. 1 milliliter equals 1 cubic centimeter. And so in lab, if we're going to measure the volume of a liquid, we would use liters or milliliters. If you're measuring the volume of an object, say a box, you would find the length, width, and height and calculate the volume in centimeters cubed. Let's talk about density a little bit. So density is the ratio of mass to volume. Or another way to put that is just to write the equation. Density equals mass divided by volume. And so as far as units that we would use in chemistry for density, could have grams per milliliter or grams per centimeter cubed. Density does vary with temperature, and next week I'll show you a demo of how it varies with temperature. So when you look at a chart of densities, it should tell you what temperature those densities are at. You can use density to identify a substance. So density can be used to identify a substance. And so, for example, the density of water is approximately 1.00 grams per milliliter. It doesn't matter if you have an entire bottle of water, a teaspoon of water, the density of water is the same. So what we're going to do now, we know that we just looked at how the density is mass divided by volume. And I want to show you how to calculate the density of a few objects. The first is a box. So I have a box of crowns and I put it on the scale. And you can see the mass is 114.5 grams. This is an electronic balance I use to make it easier to see the mass here. In lab, you may use a triple beam balance, which we'll discuss how to use. And then we have to find the width, the length, and the height. So I have to calculate, I have to derive the density of this crown box. So the width of this box is 2.75 centimeters. I am recording the measurements using sig figs, which is something we will talk about next week. And then we have the length of the box. Oops, I keep pressing my eraser. The length is 7.20 centimeters. And then the height is 9.70. I know that's pretty hard to read there on the ruler. 9.70 centimeters. So I need to find the volume of this box. And volume of a rectangle or of a box equals length times width times height. And so that'll be the numbers we just went over. The length is 7.20 centimeters times the width, which is 2.75 centimeters, times the height, 9.70 centimeters. You can get out your calculator, plug in the numbers into your calculator. Again, I am going to use the sig fig rules to record this actual volume. I'm going to use the sig fig rules for multiplication. That's not something I expect you to know yet. We will go over that next week. When I multiply this, I get 192, and it's centimeters times centimeters times centimeters, which is centimeters cubed. So then to find density, I got to go back and use that mass that was in the on the electronic balance. Density equals mass divided by volume. Mass is m, volume is v. And so the mass was 114.5 grams divided by the volume we just calculated, 192 centimeters cubed. So density equals, I take 114.5 divided by 192, and I get 0.596 grams per centimeter cubed. It is important that you have those units there. If you just put the number, I don't know what you're talking about. And so in terms of work, I would expect to see the equation you used, your work, put in your equation, and then your answer. So equation you used, your work, and your answer. And next week, we're going to learn how to use density as a, or in our next lesson, when we do some problems, we'll learn how to use density as a conversion factor. The other object you could have to measure is something that's irregularly shaped, that doesn't, you can't use a ruler to find the volume. So I have here is a rock, and the mass, I put the rock on not a triple beam balance, excuse me, an electronic balance. And so the mass equals 18.5 grams. You can see that here. And then what I use to find the volume is called water displacement. Now, this would not work if it's something that dissolves in water. What I did first is I found the initial volume. And this is just water that is colored with blue food coloring so that we could see it better in our picture. So it's not any other chemical, it's just water. And so I look at this, and you always want to read from the bottom of the meniscus. So kind of like this. It's kind of hard to see in person, but you want to read from the bottom of the meniscus. So the initial volume is 60.0 milliliters. And then what I do is I carefully put the rock in. So I took the graduated cylinder and kind of laid it to the side and slowly slid the rock in. You don't want to, this is a glass graduated cylinder. I don't want to break the glass. Two, you don't want any of the water to spill out if you just drop it right in. So then here's two pictures. This one you can't see the volume on, but you can see that I have put the rock in there. And then I focused in, so this is with the rock. And so this would be called our final volume. And so you can just see the numbers here. I couldn't zoom in enough to show you the rock in there and um, to show you the rock at the bottom and the numbers that you need to see. So again, I'm going to read from the bottom of my meniscus here. And so it's 68.0 milliliters. So then I want to find the volume of the rock. So the volume of the rock equals the final volume minus the initial volume. So it equals 68.0 milliliters minus 60 milliliters. Again, I'm going to use sig figs for the answer. So the volume of this rock is 8 milliliters. Now that I have the density and the volume, now that I have the mass and the volume, we can calculate the density. So the density equals mass divided by volume. The mass of the rock was 18.5 grams that we saw from the electronic balance. We calculated the volume as 8.0 milliliters. Plug that into your calculator. Again, I am going to round for sig figs, which we'll talk about next week. I get 2.3 and it's grams per milliliter. So in the two examples I did today, the rock and the box, we had density units. Oh, I'll do that. We had density units that were grams per centimeter cubed and grams per milliliter. The grams per centimeter cube, which I was using a ruler to find the volume. The grams per milliliters because I used a graduated cylinder to find the volume. And so the next lesson we have will be doing density problems. That'll either be a video or in video if you're remote or an in-person lesson. If you have any questions or concerns about this lesson, please send me a message. Thanks.